Okay, we're starting section 4.7, completing the square. Now, completing the square, we're gonna see two real cases. First case is a simple one where the coefficient of the quadratic is 1, and then we're gonna see when the coefficient of the quadratic term is different than 1. If we look at the first example, obviously the coefficient of A is 1. Then we have B is 12 and C. We have to find C, so it is a perfect square. Now, a perfect square trinomial, you have to remember from concept what it was, right? Remember, if you had anything like this, x plus 2 square, it became what? X squared plus 4x plus 4. And that was your perfect square trinomial, because from a trinomial you could factor it back to this one. Now, if you remember from Newton's binomial, when we had something like this, s plus b what happened? We had this, a squared x squared plus 2ab plus b squared, right? This would be like the general case, but we're looking at a specific case where a is 1, so you know any number multiplied by 1 is the same number. Property of identity property of multiplication. Now, in this case, we have a 12, and say, oh, what do we have to do first? Well, if you notice here, in the middle term is 2ab. Since a is 1, it will just be twice b, and we're trying to look for that number. You see over here, a number squared, which would be c. So the first thing we have to do is divide the middle term, or 12, by 2. What does it give us? 6. Now, that would be what? That would be the value of b, but we don't want b. If you notice, we want this guy over here, which is c. And what is c? C is this guy, which is b squared. That's why in the second step we have the result of step 1, which is c, we square it. So it's going to be 6 squared, and what is 6 squared? 36. Now, because we're looking for that value c that would make this a perfect square, we know that c would be what? 36. So we have our perfect square trinomial right there. So when c equals 36, we would have our perfect square trinomial.